this video, we are going to explore what is meant by polarization loss factor. Consider if we have an antenna which is having some sort of polarization, and if there is an incident wave which is of different types of polarization, we want to find out whether our antenna will receive that incident signal or not. So this polarization loss factor gives an idea about how much power that antenna will receive. So let's explore what it is. Let's first start with an ideal case. Consider a receiving antenna. For this receiving antenna to have the perfect receival, the incident wave on this antenna has to be the same polarization as that of this antenna. So let's see what it is. So if my receiving antenna is vertically polarized, that is, this is the orientation of the electric field, you can see that the electric field is oscillating in vertical direction, and if I am getting the vertically polarized signal, this antenna can receive all the signals because both the antenna and the received signal are in the same polarization. So for the perfect receival, the antenna and the received signal has to be on the same polarization. And let's consider if that is not the case, if our received antenna is vertically polarized and another type of signals are incidenting on it. So let's see, like this is my received antenna system. If these sort of incident wave is going to be incidenting on this receiving antenna, like right hand circularly polarized incident wave, left hand circularly polarized incident wave, or linear slanting wave, linear horizontally polarized wave is incidenting on this vertically polarized antenna. Let's see how it will interact and how much power this antenna can receive. The measure of how much received power will be lost when the polarization of receiving antenna does not match with the polarization of incident electromagnetic wave is given by the factor polarization loss factor or polarization mismatch loss. So let's see how this can be calculated. So consider an incident wave which is given by the expression EI equal to rho I EI. So this is the vector form where this rho I represents the unit polarization vector showing in which direction this is polarized. So if it is vertically polarized, the vector will be like vertical. If it is horizontally polarized, the vector will be horizontal. So this is that unit vector. And the receiving antenna signal can be electric field can be given by the expression ER equal to rho R ER. So similarly, rho R is the polarization vector for the receiving antenna. So the polarization loss factor is defined as the dot product of the both these unit polarization vectors, that is the unit polarization vectors of the incident wave and the receiving antenna, which is squared. So this is how the polarization loss factor is defined. So if the angle between rho I and rho R are phi p, it can also be written as cos phi p square, because we know that A dot B equal to AB cos theta, and here in this case rho I rho R cos phi p. So rho I and rho R are the unit vectors, so its magnitude is 1, that will result in cos phi p square. So this is the expression for polarization loss factor. So let's see some of the common examples, like what will be the polarization loss factor if our received antenna is vertically polarized and some other sort of polarization is incidenting on it. So let's see that. So here this one, this yellow colored square I have drawn to represents the received signal polarization vector. So I have just magnified it to see that. And this dotted line represents the polarization vector of the incident signal. So here you can see that both the receiving antenna and the incident wave are in the same polarization, that is both are vertical. So both the signal are in the same direction. So in this case, the angle between this, that means the phi p is equal to 0. So it will give the polarization loss factor as 1. So in dB, it will be 0 dB. That means that if both the received antenna and the incident signal are in the same polarization, they will be aligned and there won't be any loss. So it is 0. So consider the case if I have the vertical received antenna and the incident signal on it is like a slanting linearly polarized. You can see that there is some misalignment between these unit vectors. So this is the vertical one and this is the received one. So there we can see that uh, there is some misalignment angle. So based on that, we can calculate the polarization loss factor. So if it is like 45 degree, it will become cos 45 square. That will be the polarization loss factor. So we can convert that into dB and that will give us the power loss in dB. So in this case, my antenna is vertically polarized and the incident signal on it is horizontally polarized. So here you can see that angle between the incident signal and the received antenna is 90 degree. So the cos 90 will be 0. So the polarization loss factor you will be getting at 0. That means if you convert it into the dB, it will be giving you as the infinity. That means that if both the um, polarization are out of phase, there won't be any reception. That means it won't be accepting any signal if both are in opposite direction. That is, vertically polarized antenna will not receive anything from the horizontally polarized signal. This table gives a quick overview about what will be the received signal if there is any mismatch of the polarization of the antenna and the incident signal. So this means that if both the receiving signal and uh, receiving antenna are in the same polarization, the loss factor is 0 dB. That means both are aligned, there won't be any loss. So if our receiving antenna is vertically polarized and received signal is horizontally polarized, so you know that there will be an angle of 90 degree between these two polarizations. So it will result in infinite polarization loss factor, or we can say that it won't receive any signal. So in this case, we can see that if it have a vertically polarized signal, if we are getting any right hand circularly polarized or left hand circularly polarized signal, the loss will be minus 3 dB. So let's see how you can understand this. So this is the right hand polarized wave electric field component. Here you can see that it has both EX and EY component. So it is like it will be having both horizontal component and vertical component. So for the right hand circularly polarized, this is the equation, and both left hand circularly polarized, this is the equation. So here you can see that it will be having both X and Y components, and this is the magnitude. So it is like equally distributed in X and Y direction. So if you are considering that this wave is incidenting on the vertically polarized antenna, so in case of a vertically polarized antenna, you can see that it is like it will be having only Y component. So as this RHCP has both X and Y component and vertically polarized signal antenna has only Y component, this will be receiving this Y component of the received signal, but it will not receive that X component. That is why we are having loss of 3 dB when we consider a vertically polarized antenna and the received signal of RHCP and LHCP. So this is the loss that will be occurring in this case. Next thing is if you have a right hand circularly polarized receiving antenna and a left hand circularly polarized signal is incidenting on it, it won't receive any signal. It will produce 100% loss. So let's see what is mean by this. So for that, I have considered both RHCP and LHCP, the signal propagation, and this is the tip of that electric field showing how this variation is happening. So here you can see that in case of RHCP and LHCP, the rotation is like it is in opposing direction. So the rotation of electric field in RHCP and that of LHCP is in opposing direction. Because of this one, this RHCP will not be able to accept anything from the LHCP signal. That's why we are getting complete loss when an RHCP antenna is used for LHCP signal receival. So I hope you get some idea about what is mean by polarization loss factor and how it is very useful to have an idea about the polarization of the received signal and the received antenna. So this polarization loss factor has many importance while calculating the link budget, that is means calculating the power of the received signal. um, so it is very important to understand what is mean by the polarization loss factor. Thank you for your support. If you find any of our videos useful, kindly support by liking, commenting, sharing, and subscribing. Thank you.